So far in this chapter, we've been talking about oscillations as if they go on forever. But in real life, friction exists, and a system that's oscillating back and forth will eventually decrease in amplitude and finally come to a stop. This is known as damping. And in some cases, you do damping on purpose. You want to damp oscillations. Sometimes it's undesirable, but sometimes it's very desirable. For instance, shock absorbers in cars. So let me show you 3 types of damping. Well, I guess 4 types. First, the case of a system that's not damped at all. So a system that's undamped exhibits simple harmonic motion that essentially continues forever. Now, this is not real or physical. In real life, things slow down. And so what that looks like is one of these 3 cases. First case is called underdamped. So this is undamped, and this next one is underdamped. And the way to picture this is to imagine you have the same oscillation, but it's shrinking in amplitude in an exponential way. So you have an exponential decay of your amplitude. It looks like that. So this is because with each cycle of motion, you're losing some energy due to friction. So there's 2 other types of damping. This next one is called critically damped. This is when there's enough friction to cause the system to return to its equilibrium point and stop without making any other additional oscillations. And it returns to the equilibrium point in the shortest possible amount of time. So that would look simply like this. Finally, there's the case of over-damping, where there's so much friction that the system returns to its equilibrium point within one oscillation. But it takes a long time to do it because there's so much friction or viscosity that it's difficult for the system to even move. So that might look like this. Now, a practical application of damped oscillations is the shock absorbers in your car. If you just had springs with no shock absorbers on your cars, every time you went over a bump, your car would bounce up and down many times. It would probably look like this. probably do many oscillations, and there's some friction in the system, and eventually they die down. But each time you hit a bump, it would be a very annoying sensation to keep bouncing up and down over and over again. So what we do is we put pistons that have a viscous fluid, a fluid that causes a lot of friction, that creates damping to reduce the number of oscillations that occur each time you go over a bump. Now, in a car, it's usually slightly underdamped, meaning it might look like this. You might do a few wiggles before coming to a complete stop. You won't do this many, and critically damping or over damping in a car makes for kind of a jarring ride. This is not very comfortable to ride in. So just kind of by experience, this is usually the most comfortable way to do it. Okay, so that's damped oscillations.